All right, so the next trick we're going to look at is creating common denominators. And again, we did this in 7.1. We practiced how to add and subtract expressions or terms. And so what we're going to do is just this exact same thing. So if I look at this identity, I look at my right-hand side, that's as simple as I'm going to get. So I'm going to try to turn this left-hand side into the right-hand side. Now, again, when I look at this, like as soon as I learn one of the tricks below, I might do this a different way. But where I'm at right now, I would look at that being two terms that I want to make into one term. So I'm going to create a common denominator. My denominator will be 1 minus sine x times 1 plus sine x. So if I create that as my common denominator, the first term needs to get multiplied by 1 plus sine x on the top and on the bottom. And I would end up with cos squared x times 1 plus sine x. Then the second fraction is a minus cos squared x, and it's going to get multiplied by 1 minus sine x over 1 minus sine x. Okay, so then I end up with 1 minus sine x. All right, so now I'm going to distribute through. I'm going to end up with cos squared x times 1 is cos squared x plus cos squared x sine x. Then negative cos squared x times 1 is negative cos squared x. And then negative cos squared x times sine x, negative sine x is positive cos squared x sine x. Okay, all over. Now at this point, I'm not sure if I want to multiply through or not, so I'm going to leave it like this until I decide. So I'm going to leave it as 1 plus minus sine x times 1 plus sine x, but I might want to distribute it through. But let's look to see what happens with the numerator. In the numerator, I have a cos squared x minus a cos squared x, so that's gone. I have a cos squared x sine x plus another cos squared x sine x. So I'm going to do that as 2, oops, sorry, back to the blue. I'm going to write that as 2 cos squared x sine x. So now I notice that if I keep this denominator factored, that it's never going to help me because my numerator is never going to be a 1 minus sine x or a 1 plus sine x. So I'm going to multiply through. 1 times 1 is 1. Then I've got 1 times sine x and negative sine x times 1. So I should recognize that this is going to end up as a difference of squares because these two brackets are complements or conjugates of each other. So in my denominator, I'm going to end up with 1 minus sine squared x. If you put the two middle terms like plus sine x minus sine x, that's fine. I just noticed that I'm running out of room. So then I'm going to change that as my glaring identity. I've got 2 cos squared x sine x all over cos squared x. My cos squared x will simplify and I'd be left with 2 sine x. And if I look way back up here, that's what it was trying to be. So left side equals right side. Therefore, it is proven. All right, this guy. Now, I recognize this expression on the left-hand side because I made such a bumble of it the first time I did it in 7.1, making a video that you'll never see. But what I recognize is that on the left-hand side, I have a cos x over 1 minus sine x minus a tan x. So this first term has just coses and sines. So it's going to be a lot easier if I make this term have just coses and sines. So the first thing I'm going to do is rewrite this. Let's give myself as much room as possible, as cos x over 1 minus sine x. Oh, and I forgot to tell you that you should probably pause this video and try this one on your own or just keep watching. So the tan x would be sine x over cos x. All right, so what am I trying to turn this into? Well, I'm trying to turn it into secant x, or 1 over cos x. So obviously I've got a way to go. Now, the first thing I'm going to do is create a common denominator. I've got cos x times 1 minus sine x. And so I'm going to multiply this term by 1 minus sine x over 1 minus sine x. And I'm going to multiply this term by cos x over cos x. Okay, so what's that going to end up with? Well, this term will be cos x times cos x, which is cos squared x. This one will end up as minus sine x plus sine squared x. I'm going to see my glaring identity. Cos squared x plus sine squared x is 1. So I'm left with 1 minus sine x all over cos x times 1 minus sine x. And then I've got that common binomial, and I'm left with 1 over cos x. So left side is equal to right side. All right, so go and practice a few where you need to create a common denominator.